Okay, so we know that Neil and Manny. Okay, so Neil and Manny have a different amount of money. So if Manny gives Neil $6, then Neil and Manny will have the same amount of money. So one equation we can write from this is that Neil plus the $6 that Manny gives to him is going to equal Manny's amount of money. So for the second piece of information, if Neil gives Manny $6, then Manny will have 3 times as much money as Neil. So that means that, but because Manny is now giving Neil $6 from his, that means that Manny is going to be subtracting 6 from his amount of money. Now, if Neil gives Manny $6, then Manny will have 3 times as much money as Neil. So that we have M plus 6 is going to equal 3 times N, but because Neil is giving away the $6, we're going to be subtracting 6 from there as well. Oh, yeah, and so then we can distribute here. So we have 3n. So we have 3n minus 6. So we distribute. So we have 3n minus 18 is equal to m plus 6. And then we're going to, with the top equation, we can add 6 to both sides to get m by itself. So for this top equation, we would get m equals n plus 12. So now we have this equation. So what we can do is we can plug in n plus 12 for m down here. So that way we have n plus 12 plus 6 is equal to 3n minus 18. And then we can combine the like terms on the left side. So we have n plus 18 is equal to 3n minus 18. So now we can add 18 over here to get n by itself. And then that gets us to n plus 36 is equal to 3n. So now we'll go over here. So we have n plus 36 equals 3n. So we can subtract n from both sides. So we get 36 equals 3n, and then we can divide, or 2n, my bad. And then you can divide by 2, so we get 18 equals n. Now, with this information, we can just plug that in to our next equation to find how much money that Manny has. So let's plug it into this equation. So we have 18 equals n, so we plug that in here. So instead of n, that's 18. So we have 18 plus 12 equals m, which is 40. No, that's not correct. That's 30. So 30 equals m. So we have, so 18 plus 30 is going to be 48, which is less than 50. So they will not have enough money. Yeah.
All right, so this was a tough problem. Not only do you have the systems of equations stuff, but trying to write equations for these two sentences is legitimately tough, because we have to remember that if we give $6 to one person, we lose $6. So that's kind of the tough part. Now, the last problem, we have, oh geez, what do we have? We have two ratios that are equal to each other. What do we call two ratios that are equal to each other? Campbell? A proportion. Now, to solve a proportion, there are several ways we can solve a proportion. Does anyone remember one of the three ways? Violet? My personal favorite, cross multiplication. That is right. Okay, so I won't do the injustice of asking you to raise your hand if you remember cross multiplication. Let's just do it. All right, so in cross multiplication, this is really the best way to solve a proportion because it will work every time, no matter how algebraic the expression gets. So we're going to multiply 5 times 3x plus 1. Now, interestingly enough, cross multiplication is just a derivation of train tracks. Essentially what we're doing is we're multiplying both sides by 5. And then we're also going to multiply across here, and we're going to multiply 2 times 25. In other words, we're just dividing both sides by 2, but this is just a quicker way of doing it. All right, so what is 5 times this binomial? There you go. What is 2 times 25? 50. All right, so now this should be something that is right in your wheelhouse. No problems with this whatsoever. So what are we going to do to both sides to get the x by itself? Subtract 5. Subtract 5. And we get 5x is equal to 45. Oh, I'm sorry. Thank you. And then what are we going to do to both sides to get the x by itself? And we get x is equal to 3. And there we go. So cross multiplication really is the quickest and easiest way to solve these. There are other ways. I don't want to say there aren't. Hello. Just one moment, Ms. Hatchett. Yes, Campbell?
I don't know if this will work for everything, but I think I found one.
You found another way?
Yeah.
Okay, do you want to show us? I would love for you to show us. So I'm going to erase this as I pass the baton to Campbell.
Oh.
Yeah, I was recording. You're volunteering to record.
Yeah, of course. Should I go? Okay, so I found that 5 went into 25 times 5. So then I know that 2 times 5, and I know that 2 times 5 is 10, so this has to be equal to 10. So 3x plus 1 equals 10. I subtracted 1. 9 equals 3x. X equals 3.
Yeah, that will absolutely work. So Campbell used the scale factor method to much success. The reason why, just to show you why, run away. The reason why cross multiplication is a little more advantageous is once you get into geometry and beyond, you'll get questions that look like this. So let's say we have 2 over x is equal to 3x plus 1 over 25. So since you have x's in both the numerator and the denominator, we're kind of stuck. We can't use a scale factor or a side length ratio, which is the third way. So in this case, we can still do cross multiplication, and we get the 50 is equal to x times 3x plus 1. And then this allows you to factor and solve like any other quadratic. So that's the advantage to cross multiplication. Does that make sense? Yes. All right.